Welcome to the Electra-Med Edge, where we explore the science, technology, and innovations advancing human performance and patient care through precision measurement. I'm Andy, Clinical Sales Manager at Electra-Med, and I'm excited to have you join us as we launch this new series. Electra-Med is proud to be a service-disabled, veteran-owned small business, founded in 1975 as a biomedical service organization. Nearly 5 decades later, our mission remains the same: to deliver not only cutting-edge equipment and supplies, but also the support of the sale, meaning we're here for our customers long after installation and training. Today, Electra-Med provides full-service solutions across neurology, cardiology, physical medicine and rehabilitation, sleep diagnostics, respiratory care, and U.S. government contracts, serving clinicians, researchers, academics, and performance professionals nationwide. Through Electra-Med Edge, we'll bring you conversations with experts, insights into emerging technologies, and real-world applications from across these fields, all aimed at advancing human performance and clinical precision. Let's get started. Hello, everybody. Welcome to another episode of the Electra-Med Edge. I'm Andy, Clinical Sales Manager with Electra-Med, and today I have the great honor to introduce Dr. Michelle Harrison of Technavance. Dr. Harrison is the co-founder and president of Technavance, a small, family-owned engineering and manufacturing company specializing in human physiology research instruments. Her background includes working in both clinical and research laboratory settings. From a research perspective, her expertise is in cardiovascular and exercise physiology. Since founding Technavance was a logical career path for her, she has evolved Technavance, and one of the major strengths has emerged to be bridging the gap between novel research questions and the availability of technological solutions to help answer them. So a great segue and great portion of this podcast. Most recently, Technavance has helped develop a number of next-generation LBNP systems engineered for MRI compatibility, parabolic flight, positive pressure capability, and integration within the environmental chamber. Join us as we welcome Dr. Michelle Harrison. Dr. Harrison, great to see you today.
Thank you, Andy. It's great to be here.
Oh, you're welcome. So, Dr. Harrison, if you could just please give a little bit of a background of kind of what you do, what Technavance is, and just a brief description of the company as a whole.
So the company as a whole is family run. We're very small. There's only 3 of us. So I'm the president, and then I have 2 sons, 2 of my 3 sons that also work for Technavance. So we wear many hats. We each have very distinct roles that we play. My role is to guide kind of day-to-day operations. And then I do, bookkeeping and accounting, and I order things and do inventory. Curtis does engineering and software, and then Nathan does sales, marketing, manufacturing, and customer support. So we have all bases covered, but we're pretty small. And so that's
Great. So obviously, small family business, love to see it, love to hear about the successes. Maybe you can help share for our audience who doesn't quite know yet, but what populations or organizations does your company primarily serve? Is it students, athletes, research facilities? Maybe you could answer that a little bit more in depth, please.
Sure. So we make physiology research equipment, which you alluded to in the beginning. And the LBNP chambers, for instance, are lower body negative pressure chambers. And we also make something called a baro chamber, and they're all involved in cardiovascular and exercise physiology research. And so we serve primarily researchers. They're generally at the leading edge of their fields where they're asking novel research questions, and they can't find the technology to be able to answer those questions. And interestingly for us, first, we should talk a little bit about the physiology, maybe. So our
Sure.
LBNPs are lower body negative pressure chambers. And so what you can do is you can put a person lying on their back in the chamber, and you seal them at the iliac crest. And then if you apply negative pressure to the chamber, you can essentially take the blood that's around the heart and you can pull it to the feet. And so it's used in research areas such as hemorrhaging, because you can imagine if you're hemorrhaging on a battlefield or from trauma, you're having that same effect. They use it in microgravity, so or acceleration. Anytime when you want to look at these fluid shifts.
Sure.
And another big one is blood pressure control. And our baro chamber does the same thing, only it's applying pressure around the neck so that you have the kind of this ability to look at blood pressure control. And so primarily our researchers work at academic institutions, hospitals, and more recently we've had a lot of small startup companies reach out who are looking at sensors, like physiological sensors, because that's a big part of new technology right now.
Yeah. Now, wearables is always going to, I think, professionally be at the forefront of a lot. How do we take all the measurement devices from the lab, make it a little bit smaller to be put into systems like yours? So obviously you have a very extensive background, and maybe it influences the way you collaborate with researchers and engineers. Maybe we can talk a little bit about how your equipment and your instrument really helps to further the science. You just mentioned that a lot of these researchers are at the forefront. So maybe we can talk more about how that impacts them and impacts you as Technavance.
Thank you. And it comes down to, if you imagine in the research world, we have these new questions being asked all the time. And quite often technology is our limiting factor. And so if the technology can meet that research question and answer it, then it often opens up a whole new space. And so it's almost like a cyclic thing. So technology enables research, and then research ultimately improves human health as we can learn more and more about, in particular, human physiology.
Sure. And we bring up physiology quite a bit. Obviously, my background as an exercise physiologist as well. When you talk about physiology, and especially your background in cardiovascular work, what do you notice in these chambers that is maybe being studied, or some of the individuals that you work with, and either whether it be cardiovascular, you mentioned bariatric around the neck, and then around the iliac crest. What maybe specific cardiovascular events are they looking at?
Most of the time, so they're looking at, so depending on the research question, there's a lot of things you can do. If there are cases where, and physiology is really just the study of how our bodies function. Sure. And so some of it is just understanding. First, you have to understand normal physiology before you can then approach it and look at pathophysiology or during disease. So, for instance, you can look at during hemorrhaging, for instance. Thank you. And is a part where as you hemorrhage, you're losing blood. So our chamber is able to mimic that, because you can pull blood away from the heart and continue to pull blood away from the heart. And eventually, if you left someone in an LBNP chamber, they would pass out, which you don't do, but that's kind of where you're heading. Okay. And so with hemorrhaging, there are people who can compensate very well physiologically. So they would survive more trauma and more loss of blood than another person, but we don't really understand the mechanisms why. And it becomes very important if you're, again, on a battlefield or in a trauma situation where you're trying to triage. Because if someone was more vulnerable to that effect, then you would move them first. Okay. And so there are a lot of researchers out there that are looking at compensatory mechanisms and why they are different in different people.
Gotcha. Interesting.
So that's one pretty big example. Yeah. Another one is just orthostasis, which is because we have evolved in gravity, and when we stand up, blood gets pulled to our feet. We have mechanisms in place to return blood flow to the brain. Okay. And so our chambers can simulate that physiology as well, where they can then study why are some people more vulnerable to fainting when they stand versus others.
Interesting. So really talking about the orthostatic hypotension as well. So yeah, I guess we could get into just something along the lines of tidal volume, or not tidal volume, but blood return, vascular return. If there's an issues with the lower extremities, the valves coming back up through the legs, right, to potentially some vascular diseases there.
Exactly. And vascular function. And the other thing is there are people who are, when you put people in these chambers and you start to look at blood pressure control, there's an enormous variability, which is part of humans. There's a lot of variability in how we respond and our physiology. And so the question becomes, how do you get at these mechanisms, these little changes that could make one person more susceptible to an event versus someone else? Considering we're all humans.
We're all, yes, all humans with our own little quirks when it comes to our own physiology, right?
Exactly. We have personality quirks and we have physiology quirks.
Yes. Maybe one day we'll get to the bottom of it, but no, that's great. So my next question is, obviously, I find your chamber very interesting, especially as we look at cardiovascular function. Do you happen to maybe have any examples of pulmonary function as well, or any pulmonary testing that's done in maybe the bariatric chamber?
So we don't do any of that. We don't
Okay.
do any. So I say we don't do pulmonary function testing. That doesn't mean researchers wouldn't also be looking at that.
Okay.
The important part of respiration and how it would play a role in our chambers or people doing that kind of research is respirations do affect blood flow return to the heart.
Sure.
And so quite often a researcher would have a respiratory belt
Okay.
because it affects heart rate and blood pressure. So those things are still entwined.
Right.
Though our instruments are not specifically targeting that.
Okay. But as I think a little bit into this as well is somebody maybe who has a COPD or some other obstructive pulmonary disease and how that's going to affect stroke volume and cardiac output. Would you say that lines up in that as well?
I'm sure there are some researchers who would look at that. I'm not as familiar with that side.
Okay, fair enough.
But interesting.
Yeah.
Thank you, Andy.
I'm sorry, I didn't mean to cut you off.
No, that's okay. I was just thinking of different environments when that would merge a little more, but it would depend on the research question.
Sure. And that's kind of the fun thing about being on the device side is working with researchers who you almost have to start backwards working with them, right? Is to say, hey, what is your end goal or what are you trying to investigate or trying to find? And then we work ourselves backwards to either a targeted question or even an open-ended question of it's like, hey, we're not quite sure yet. And sometimes we come up with an unexpected result that is always good or bad, but just the part of science, right?
Yeah, and actually that happens a lot when we look at, so often a researcher will approach us and they'll want something, they have some idea in their head of what they want or need. And it can be a modification to instrumentation that we already have, or it could be something totally new. And our initial conversations try and get at that idea in depth because it's not only, the researcher and what they kind of think they're going to do with it, but it has to tie in with engineering constraints. And so it's also, what does engineering allow? What is physics going to allow in this situation? And so you have to do a lot of communicating to make sure. And often it is just a little bit different.
Right.
Go ahead. You go. I was going to say, historically, many of our instruments were lab-made, so they have been made for a long time, decades. The problem with that, or the barrier with that, is it required, in-lab knowledge with engineering, or it required institutional engineering, resources to kind of be able to build it. And so where we come into the picture, we're the first company to commercially make these things available. And so now researchers can look at the field and think, oh, I want an LBNP chamber, but I need it to do this because they're already in the literature. And we're getting those kinds of questions a lot.
Excellent. So that kind of leads me to my next point here of talking points is engineering for complex environments. We mentioned, or you've mentioned before, you use systems used in MRI environments, parabolic flight, and other extreme conditions. What makes working or engineering in these environments so challenging?
It really just puts there's engineering limits to everything. There's constraints, but the minute you delve into a more complex or extreme environment, those become a little more rigid. And so you're trying to work around those all the time. And so we've done MRI compatibility now, which I think is pretty powerful. MRI as a technology is extremely powerful. It allows you to get at, so it allows visibility into a lot of these like complex human physiology questions that we just don't quite understand. And so, you can't have anything magnetic, you can't have anything conductive. So now we're looking at having to build a chamber completely out of plastic that's still going to hold pressure. And then you have other considerations. You have imaging artifacts. If the person were to move, our chamber could potentially interfere with the MRI instrument. And so those are sort of engineering constraints as examples.
Sure.
And then you have just human, and one of our big, from a human perspective, is subject size variability.
Sure.
If you think, even within the adult population, if you think of the smallest person and the biggest person there is a huge range.
Yes.
So the equipment has to adjust for that. So luckily in-house we use me as a version of the small, and we use Nathan as a version of the big. So we try and, map out how our instruments will work. But specifically within MRI, you have the bore of the MRI, which is completely rigid and can't change. And then our chamber has to fit in, and then a human has to go inside. So you're very limited. So those are kinds of things you have to think about.
Sure. So that, absolutely. I mean, I think both as a physiologist and researcher and engineering component, bringing all of that together is how do you best figure that out? So while I'm not sitting in your seat, I'd imagine it's sometimes a headache, but it's also a fun challenge to try and tackle.
Oh, absolutely. We have this little term we've coined in-house, because if you think of when you're solving a problem, and you say it's engineering related, but it has to be safe. You care about ultimately human safety comes number one. We care about the performance of the instrument, and then we also care about its usability, because you want it to be user friendly.
Sure.
And so if you think of those three things, there are a lot of ways you could solve this problem you have, but the elegant solution is the one that solves all three. And it does it, simply and directly. Sure. So it started as a bit of a joke, but now we've coined this term internally where we're always looking for this elegant solution. So it can be fun and it can be challenging for sure.
Elegant solution. I really like that term. That's interesting because yes, trying to solve a problem directly and simply usually is never directly and simply in the beginning, right? It's always a chaotic dance of how do we get to this elegant solution. That's fantastic. I love that term. So one question, we've talked about some extreme environments, and I think for a lot of our listeners who are learning, especially as we have some younger undergraduate and graduate student listeners who are learning more about space and other hypoxic environments and hyperoxic environments. So one thing I'm actually kind of genuinely interested in is how do you all introduce or work in parabolic flight into these environments, or what is your experience with that?
So that one was extremely interesting for us. So and it was a great opportunity. We had already sold an LBNP chamber to a researcher at Texas A&M University, Dr. Ana Artilles. And so she reached out and she was submitting a proposal to do research during parabolic flight, during microgravity. And so she asked us if we could build the chamber. And she ended up getting funded, and so we built the chamber, which was one of the more challenging tasks we have done, or modifications we have done, because that environment is highly regulated, and it was through France, and Novaspace is a company that owns the plane. And so as a researcher, if your proposal is accepted, then an engineer gets directly linked with anyone that's putting any equipment on that plane, because you imagine that it's going to go on a plane with a lot of other people in a dangerous environment.
Sure.
So there was a lot of, and it's all about structural integrity. And it was really interesting because we, it's not just during the parabolic flight, but you're worried about a catastrophic event where you couldn't have fragmentation, you couldn't have anything shatter because it would put people at risk. And so it was a great experience. We learned a lot. And Curtis was Curtis then interacted with these engineers at Nova Space. And then the week before the flight, everyone goes, and so we had the opportunity to also go, and so there were 3 flight days, and each one of us got to fly a day, and we're in the LBNP chamber, and so it was a great experience. I'm familiar with the other physiological equipment, but Nathan and Curtis were not, so they got to see it in action at zero gravity. So it was a super cool experience for all of us. And we're very grateful to Dr. RTS for allowing that to happen.
Absolutely. No, see, that's something that really does help, is furthering the science, right? Taking it to these extreme environments and figuring out hey, how are we going to make this work in here? I both as a physiologist myself, but also as kind of a gear nerd, I think this is awesome. We could probably spend 3 more hours just talking about that little snippet in your family and company's history. But that's excellent. So I guess as we move into here is what really stemming on this particular scenario, going from a concept to a solution. Maybe you could help walk us through in this particular case how it went just from the concept of wanting to do this all the way up to the fully developed instrument.
So, and over time, we've kind of developed our process, though everything is still dynamic and changing because you react to things changing. But
sure,
we initially, when someone reaches out and has a specific request, if it's a modification, something new, which we talked about a bit previously, we have this very in-depth discussion to try and get at what do they want and what is that going to do? And we call that engineering with purpose, because we really want to understand what we're going to do with that instrument, what's going to be done with that instrument. And then we take it in-house. Curtis draws up the first design, and then we meet as a team to discuss that design at that level and any outstanding questions he may have. And then he goes back to the drawing board, and we'll do that 3-4 times internally until we feel like we have come up with a reasonable design. And throughout that process, if we're reaching these little barriers or these forks in the road where it's we have to decide A or B, then we get the researcher involved and say, hey, these are our options. What should we do? And then after we've done that a few times in-house and we have a pretty solid design, we meet again with the researcher. And for that meeting, we also suggest that anyone comes to the table on that one that's going to deal with the instrument. So students in the lab, collaborators, sometimes for our MRI compatible system, we were in contact with a physicist, MRI expert that guided us. And so everyone comes together at that conversation. We find that the more voices there are at the table and the more experiences and perspectives, the more likely we are to catch a design flaw that might be a problem later. And then after that, we finalize it and build and ship. So it's lengthy, but it's an interesting process for sure.
Absolutely. And really what I just took from that response is fantastic. But if maybe you've coined this term or not, or maybe, but it sounds like you all at Technavance have the Technavance triple threat in terms of understanding science and kind of understanding what these researchers are going through, but then also looking to bridge the science as the second part and engineering as the third. And we see in academia as well as new potential professions is the bioengineering and bioscientists. So my question to you is, how important do you think it is for engineers, especially whether it be in-house or others that you're working with on a project to really understand physiology, whether it be a full in-depth of human physiology or anatomy. But how important do you think it is for engineers to understand that?
Thank you, Andy. I mean, in a perfect world, it would be great if, your engineers understood physiology and your physiologists understood engineering. That's not always the case. And I guess the only way you make up for it is to have really clear communication and open explanation. So you can ask questions and then get solid explanations. In-house for us, I feel like we have that covered because I come from research physiology and Curtis is, all engineering. And now Nathan, who manufactures, has done a lot of them. So he's got a pretty strong voice at the table just to say, oh no, that engineer might think that works, but when I try and put that together, it doesn't work so good. So
Yeah.
yeah, it's a thing. And I think because I have had exposure, I worked in research.
Mhm.
My take on it is really always from the user perspective, which is a little different than how the engineer would look at it. And so if you have those bases covered, I think you end up with a better product.
Absolutely. So again, tic-tac-toe on the triple threat there. You have
Yeah, I really like that. We're going to bring that one in-house.
well, I think we also just found the title of our episode as well. So
There you go.
that's great. And I think you're right, because yes, it may draw well on paper, but once it actually goes into the manufacturing process, there's some hiccups. And but then also understanding the physiology too is like, hey, that's just not how physiology is going to work, right? I guess the one perk of our field is human physiology hasn't necessarily changed over the last thousands of years, but what has changed is how we understand it a lot better. And what mechanisms we need to investigate, or how we need to look at that some more. So,
And that's what guides us, right? Like you need novel research questions so you understand human physiology better, because the ultimate goal is to improve human health. And so
sure.
that's just a part of that process. And we cure disease all the time. We make better and better medications. So we're certainly getting better over time as our understanding of human physiology deepens.
Absolutely. So yes, as we further the science, further our understanding, it's great. And as we start to look towards the future here, maybe what are some of the biggest opportunities that you see as for innovation within physiological measurements, physiology research? What's something that you maybe have on your radar or horizon?
We've talked a lot about sensors. I think sensors are really big right now, wearables, getting all this physiological data. I think a lot of them are coming out a little quicker than we've been able to validate them. So I don't know that they're all equally as good, but that just takes time. And so sensors are a big part of, I think, where we're going. The other big one is just space in general, which involves both physiology and instrumentation. You hear all the time about this, oh, we're going to go to Mars and we're going to build a lunar base on the moon and people are going to live there. And we, from a physiological perspective, we evolved with gravity. So being able to stay in space for a long time right now for humans is really we're just not capable of doing that yet. So there's a huge push right now to understand the effects of space on human physiology, and then how do we mitigate them?
Sure. Especially with the Artemis 2 mission that just occurred a couple
Yes.
weeks ago, and learning more from them about that, and what their body's responding to. I think I saw one clip of all those astronauts physically being helped to walk again, even though they were in space for a relatively short duration, what we would consider here, a couple
Yes.
days, I believe.
Yeah.
But even that, let's see, no, I don't want to call it sarcopenia, but muscle, I don't want to call it muscle wasting, but maybe I'm on
We
the right
actually
track.
do get muscle wasting.
Oh, is that
And
okay?
part of the not being able to stand up is blood pressure control, which ties right into our instruments. So they are trying to mitigate that effect. If you imagine, we just talked about orthostasis. So on Earth, blood is being constantly pulled to your feet when you're upright. And so you have mechanisms in place where the body says, hey, and it's always the brain, because brain blood flow is the ultimate. And so our bodies control brain blood flow very well. And so the minute we stand, blood pulls to our feet. There's all kinds of regulatory systems that kick in and say, hey, we need blood to flow to the brain. Well, when you go in space, you lose that entirely. And the opposite affects where blood translocates to the head. So it messes with that orthostatic mechanism. So then when we come back to Earth, we don't have that capability anymore. We regain it,
Sure.
but we don't have it right away.
But we still don't really know the long-term lasting effects of it, right? Say somebody who was truly deconditioned, right? Maybe somebody in a sedentary lifestyle, they were to go up versus someone who, I'm going to go full other end of the spectrum here, an accomplished triathlete, right? Who typically have, or even a biathletes who typically have the highest VO2 max out of anyone, what that comparison would actually look like too.
Absolutely. And that's a good point. Because if you think if you're starting at a higher fitness level, then you have more drop before you're dropping into the red zone with these things. But we just don't know enough about that yet.
Sure.
And so there's a lot of research that needs to be done to push that forward.
Absolutely. So that kind of leads into my next question that we came up with. So you see, or we've learned that Dr. Harrison and Technavance have really worked in a lot of complex environments and working with complex research questions. But where do you see the future of custom engineering continuing to shape the future of research?
I think it's going to be just like it is, because that cycle we've talked about just keeps going. New things will open up, like new areas, which space is, but they've already been trying to mitigate these effects for a while. They're just getting better and better at doing it. And I think from a technology perspective, we're just going to get quicker. And then, I don't really know the answer to this, but how will AI play a role in that? AI is the big hot question, a hot topic right now. But how will that expedite my thought is that things will just move quicker because technology in general is getting quicker.
Yes. Absolutely. So this has all been fantastic. And as we've talked about space flight, so we'll kind of start to land the proverbial plane here. And one thing we always like to end on is, obviously you're a professional, you have an extensive background and a lot of working knowledge. What advice would you give to either current researchers or maybe even young researchers to working in complex measurement challenges like that you're all experienced with?
I think it comes down to perseverance. You really do have to persevere. The initial questions are driven by curiosity. I think people in general who do research are curious people. I'm sure that most of them can think back to even when they were young and watching something happen and think, why did that happen? Or how did that happen? So you're innately curious. That's what drives research. But you come across a lot of barriers with research too. And so you really have to persevere. And in many cases, we talk about this percolating research question. So you have this idea that's been uncovered by something recent you did in the lab or you were exposed to, and then the minute you're thinking about that research question, you're also thinking about, well, how will I answer it? And if the technology is available, I think there's a lot of percolating research questions sitting on mental shelves right now, just waiting for the technology to come.
Sure, absolutely.
But you have to persevere. It does take a certain intestinal fortitude to keep going.
Yes, and with funding, and we won't get too much into that, but you always have to have a lot of hooks out to catch the big fish, right? And that's just that's really part of it. So
absolutely.
Well, great. Well, Dr. Harrison, as we kind of again really bring this plane to a land here, where could people find you to get either more information on Technavance, maybe some of the products or solutions that you all offer?
They could certainly reach out to me. And then we have a website, so www.technavance.com.
Okay.
And we pride ourselves on customer service, which is driven by Nathan. And so if you were to put in an inquiry on our website, you will be guaranteed a response within maybe an hour or less.
Excellent. Wow, that excellent.
He is very eager to chat.
Wonderful, wonderful. Well, I'd love to have a conversation with him one day. He has as much vigor and passion as you do. It would be another fantastic conversation.
I think he exceeds my passion by far.
Is that right? Well, that's another beautiful thing of having a family-run business and keeping it so tight knit. So, well, great. So again, Dr. Harrison, thank you so much for your time here on the Electra-Med Edge. We appreciate it, appreciate the collaboration, and look forward to speaking with you in the near future.
Great. Thanks a lot. And it was good.
Yes. Thanks again for tuning into the Electra-Med Edge, where innovation meets precision in human performance and clinical care. To learn more about Electra-Med's full range of medical equipment and supplies, spanning neurology, cardiology, physical medicine and rehabilitation, sleep diagnostics, and respiratory care, visit us at electramed.com. Also, check us out on LinkedIn and Instagram at simply @Electra-Med. Be sure to follow, subscribe, and share this episode to stay on the cutting edge of healthcare technology. Thanks again for joining us, and we'll see you on the next one.